Hello and good morning. One more video for Wednesday, September 10th, 2014. This video will be covering the information from Chapter 5 and a little bit of information from Chapters 2 and 3. One thing I want to show you before we get started is a couple of different views of ArcMap. What you're looking at here under the table of contents, this lists your data layers. Right now, the world is active. The world population is not the active data frame, so we're going to focus on the world. And I want you to look at a few things. When I have this button clicked, I'm going to do this, move some things around. I can see how I don't see the rivers, and some of the cities are missing. It's like, oh, wow, what happened there? I can move rivers up to the top, and I can see the rivers. Some of the cities are missing mainly because of the way that's set up, but I'll show you that, how to deal with that in a different video. So if I want my lakes to show up, I can move them to the top. So what's happened is I've got my land areas below the rivers and lakes. If I turn that off, then you can see pretty much everything. Put the cities back in there. So that particular button is for listing by the drawing order. So what it means is it draws this one first and then puts this one on top of that and then this one on the next one, rivers and lakes. So if lakes is at the bottom, it's underneath land areas and you can't see the lakes. This button here lists by source. So this tells you where it's looking for the data. So in this case, this shows where the data is coming from. And if for some reason, like in the video that I put up about how to find your data if your map is blank, if what it says here does not agree with where the data actually is, then the data doesn't show up. List by visibility, this list by what's turned on and what's turned off. I never use that. List by selection, that will come in handy later in the semester. And this is just options of how you deal with the table of contents. The two most common ways of listing it are list by drawing order and list by source. And if I try to move this around, I can't when it's under list by source, but I can if it's over here. Another thing, harkening back to what to do if you can't find your data, if your map is blank. When you click on this, you see how it says country outlines? Go to properties, go to source. This will tell you what it's actually called, or where you can actually find where it should be found is in here. This right here gives the actual name of the data, country 07 DEMOG. Because if you were thinking a while ago, it's like there's nothing in that when you try to set the data source, you go here and you're looking for the data source and go through to try to find it. And you go here and you say there is nothing called country outlines. You'll need to go and look here to see what the actual name is. And I've breezed right past that in the other video. Okay, so that's just a little housekeeping there. Now that we're ready to talk about Chapter 5, I'm going to leave my screen up as it is. I'm just using the lesson that we had as it's going to be used for my example because it has one of each of the types of vector data in this little exercise. Okie dokie. So Chapter 5 is basically the introduction to geospatial data and GIS on an academic level. And so we know that Geographic Information Systems, that's what GIS stands for. And this chapter is mainly about how we represent geographic data in the GIS. So what we are using an ArcMap would primarily, and I say primarily because we will use other types of data models, we primarily use the vector data model. We will use some raster data models later, but primarily especially in these first exercises, we are dealing with vector data model. And what does that mean? It means that we are showing data as discrete entities. See my whole screen here? Look at my whole screen. I've got a lot of white space in here. In that white space, there's no data. There's not any data here. The data is in these discrete little packets here. So I'm going to turn off everything except for my cities. I'm going to turn my cities on. These are the major cities. And if I zoom in, I see a lot of blank space and a spot here and a spot here. Now that's a label right there. This is not actually necessarily part of the data itself. That's a label. If I don't want to see the label, I right click here, I check off label. So there's what it would actually look like without the labels. That's the data, dots. These are called points. This is a point type data. Discrete point. That means it's a one-dimensional space on the map, a single point. The other, in the vector data model, the other two types are lines, are rivers. And a line is simply a connection of points. If we zoom in close enough, we see where the lines bend and curve. These are called vertex or vertices, V-E-R-T-E-X, or we have more than one, V-E-R-T-I-C-E-S. So these are lines. That's another type of discrete data. And finally, we have polygons. In this case, I've just brought up the lakes as an example. Another example of polygons are the land areas. So a polygon is also a two-dimensional, whereas the point is one-dimensional, the lines are two-dimensional, the polygons are two-dimensional. They are lines that enclose, they are essentially closed lines. They enclose a space. So those are your three, your points, your lines, and your polygons. Sometimes you'll see the polygons are mentioned as areas. Sometimes it's point, line, area, depending on who is referring to it. Older people who've been working in GIS for a longer period of time, we jump right into the polygon. We just call it polygon. A few years ago, people tried to be more accurate and say, well, polygons are actually a specific type of closed space and blah, 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 blah. So it should really be called an area. But we all go back to using polygon. The book calls it a polygon, and you can read all about that on pages 112, 113, and 114. All right. How did we get this data? A long time ago, people had to do what's called digitizing, and what they did was they had a map that they would put on. What was called a digitizing pad, and I'll show you one of these. So here's somebody with a digitizing pad. See, he's got this map on there, and this thing was called a puck, not a mouse. It's puck. It's kind of like a mouse. If you could see closely, you would see a keypad on there. So it was like a mouse with a keypad. This little thing right here, this where the lighted area, what he's doing with that is just absolutely horrendous. I used to have to do this. It's horrible. He has to trace for every point, line, or polygon layer. He has to trace those out. Points are easy. Points, you just click on it, but you're done. Lines and polygons were horrible because you had to click, and when you come to a curve in the road, you had to click, and you had to punch in a special code for that specific node or vertex, and then move to the next one, and then click and punch in a special code for that one. And if you intersected another line or whatever, you had a special code for that. It was annoying, and it was tragic if you got stuck doing that. I digitized something for 15 hours straight. I'm glad I was young. It would have killed my back these days. Now we do something called heads-up digitizing, where we can actually put a map on screen and trace on screen using our mouse or keypad or touchpad. All right. So That's what digitizing is all about. You'll be doing some digitizing as well. We don't like to do digitizing in GIS. I've noticed, though, if you're a CAD student, CAD students tend to like to do the digitizing because it's something you're familiar with. It's more like what you do in the CAD process than you do in GIS. The GIS people that go into the GIS field, a lot of us don't like to do digitizing. It could be just because I had that bad experience of the 15 hours straight. All right. We also talk about topology, Topology. Topology is the science of space, of where things are located. In other words, GIS understands the topology of this river here. I'm going to turn off that land area because it's annoying, and I'm going to make my rivers a better color for you to see. And I just wasted some time there. I could have done that a lot quicker, doing another way. Make it a dark blue and big. Okay, so this river, the GIS knows which side of this river is the right side and which side is the left side. It knows the order, each of these nodes or vertices is essentially numbered, and it knows the distance between those. It knows that they're connected. It knows what's next to what feature is next to another feature. That's called topology, being able to understand how they connect to each other and what's on each side of it. This is why GIS can calculate distances and areas, because it understands topology, or where things are located and how long things are in between each other. Okay, another type of data, we talked about discrete or vector data. Another type of data is called raster data, which is a continuous field. And the reason we call it a continuous field is as opposed to vector, where we have this line of data here, and in the white space, there's no data. Raster data will be continuous across the board. So I'm going to bring in some raster data, and there we go. I'm going to bring in some raster data. Went to the wrong folder. And I'm going to add that. It's not going to show up in here. I'm going to have to move to it. This gives me an opportunity to talk a little bit about some Chapter 2 and Chapter 3 things. Notice it says Geographic Coordinate Systems Warning. This is telling me that this is in a different coordinate system than my data is in here. And it tells me there could be a problem, but as long as all the information is in there, it will be able to locate what I need. So I'm going to close that, and I'm going to zoom to that layer, and there it is. Whoa, it's kind of crazy looking, but this is my raster data, and I'm going to fix that so it doesn't look so insane by going to properties. And you'll notice when I go to layer properties with a raster layer, I don't get as many choices across the top there. Let's go to symbology and fix this. I need 3, 2, and 1. That should fix it here. Close enough. All right, so what you see here, this is actually an area of East Texas, and I'm going to zoom in. And what I mean by continuous data is that everything within this data, this set of data, let's zoom back out to it. Everything within this area, you see the black here, and then this image, that has data. The black is still data. It has no value to it, but it's data. So I have data continuous from here to here, and from here to here. I have continuous data, and that's why we call a raster data set continuous data. As I zoom in, this is an aerial image. This is actually a satellite image of East Texas. And as I zoom in, vegetation in this case has been colored red. We'll get into why that's colored red. The water has this kind of a light blue color and developed areas. See if I can find one for you. We're in the middle of the forest of East Texas, so you're going to see a lot of red, which is the vegetation. But the developed areas are going to have, you can see the roads here, this bright blue. So that's in general how to identify stuff on here. But if I zoom in close enough, just keep zooming in, a raster data set will have pixels, little squares. And each of these little squares has a value. If I go to my Identify tool and click on this, it shows me I have a value for the red color, the green color, the blue color, but they have, each of those parts has a value to it. So, so a raster layer is divided up in a grid. The reason you see these grids looking kind of crooked instead of nice, neat squares was that coordinate system thing. So that's why I said the coordinate system chapter is so important, because if I wanted this to show up in nice, neat squares instead of these parallelogram things, I would need to work on I would need to deal with the coordinate system situation. So I can trying to fix that. I can try to fix that right now. It's going to let me. So if I go in here and I change my coordinate system for my data frame to UTM, how do I know to do this? Because I've worked with this data set a lot. You would have to know which data set, what coordinate system your data set is in. I happen to know this one because I know this one's ever so well. Say okay, yes. Now see how that straightened it up? I got a little warning that said it was not in the same coordinate system as my other data. And I was like, if I just want to look at this data and I want it to be in nice, neat rows, then I'll change that. But this is a raster data set, squares. It breaks down into squares. Later in the term, we'll work with some other raster data sets that are not images. But this raster data happens to be aerial imagery. Okay, I'm going to zoom out to all the way out to the full extent of the data and show you what by changing that coordinate system, just so I could see my my raster data set that was in here. Look what it did. It ends up cutting off part of the world over here. That's why it's important to have all our coordinate systems coordinated, have them all talking to each other. So obviously, this is not a good coordinate system to be able to use for both my raster data set and my full data set. And that's why I said I wanted to use this. This is a sort of a lecture for both coordinate systems information and Chapter 5. I'm going to break away from talking about the coordinate system for just a moment. We're going to go to world population, make this our active data frame, so I don't have to go around and mess with coordinate systems again. And so I'm going to expand that out and click the little plus sign so I can see all of the different things. And I see my world countries here. I right-click on here, I open the attribute table, and this has all kinds of information in here. My world countries, all kinds of information. This is the non-geographic data. This has information about mobile phones and phone layers and phone information and population data and all of this, all of these details in here. This is my non-geographic data. So we put in a vector GIS, we're able to put all kinds of data in this table. In the raster GIS, we can't put all of that in there. It's just not set up to take all that information. So, so if you look at this, all this non-geographic data is handled in the table. So I can select things in the table by clicking on it. If I want to select more than one thing, I can click Shift, and so I click all of these things, all of these countries. I just did that kind of randomly. I didn't have any particular choice there. And then if I want to see it on the map, it highlights it on the map. So I got all these little islands here, and a good deal of South America. What if I only want to see what is selected out of the table? You know, so say I have something here, whoops, selected here, here, whoops, here. I just lost my original. It's just I have these placed all throughout the table. And I want to see all of those. Come on. Oh, this is not. ArcMap is not happy with me right now. I had a little memory thing going on that tried to shut me down. I'll just skip trying to shift up and down and show you if I only want to see the selected items. We click there, and there's my selected items. So there you go, how to read the selection. And here's how non-spatial data or non-geographic data is handled. Clear selection. I want to see all my records, and there they are. So how do you know what's what in the table? What is this, what do these columns represent? The name of these columns are called fields. And each field has a name. So it's going to be a country name. And in ArcMap, we have requirements. You can't have any spaces. So we come up with some weird ways to call things. PPOPC _ 0725. We come up with some strange names for our field names. But that's what this top row identifies, is the name of the field. What is that characteristic we are describing in these numbers? The long name of the country, the status, what type of country it is. This gives the description. The field names give the description of what's going to be in each of the rows in that column. So a column is a field. A row is a record. A row represents a specific, a discrete entity on the map. So let's see if it lets me. If we want to zoom to that selection, I go to Selection, Zoom to Selected Features. So I've clicked on the Department of Guyana. Here it is right here. This discrete geographic region is represented by this record right here. And these are all the different attributes of that country. So a field is also called attribute. Sometimes people call it characteristic, but it's usually called field or attribute. So this can be the field name or the attribute name. It's important to remember the word field, though, because that's the word that ArcMap uses. Okay, so that's pretty much the highlights of Chapter 5. We also talk a little bit about joining tables. If you have an Excel spreadsheet that does not have any geographic data in it, you can actually, if there is a column in that Excel spreadsheet that has the same exact name or the same exact data as we have here, like if we have a column in the Excel spreadsheet with the country name in it, then we can actually relate those two tables. We can say join that tables based on this country name, and we end up with a really long table, all the data that's in here along with the data that's in the Excel sheet. So that's called joining the table. I think that's going to wrap it up for Chapter 5. There is a little bit in Chapter 5 where we talk about different types of GIS, open source GIS, and so forth. We have a whole unit where we'll be talking about different types of GIS, and we won't go into that today. Hope you have a great Wednesday. And what is your next assignment, you might be asking? I'll have that out on Friday. Since this assignment that you're working on now is not due until Friday, I don't want to overload you. I don't want to double up on your assignment. So what we'll do is we'll back it out to where the next assignment will be due on Thursday, and then we'll get back to where we have assignments coming out every Wednesday, since I got messed up on that sound thing. So next assignment will come out on a Friday, this coming Friday, and we'll get everything next week. We'll have hopefully start getting things backed up where everything, the videos, the assignments, all that comes out together on the same day. Have a great one. We'll see you the next go around.